All right, thank you. I'm going to apologize in advance. I got a lot of material, so I do have to go kind of quickly. So this is some data from the fish rescue program. Justin and I kind of been kicking it around for a while, and finally came up with, probably after 3 or 4 years of discussing it, what we decided we wanted to do. So in the past couple of decades, there's been an increase in interest on these intermittent streams. And as human demand for water increases, as well as global climate change, a lot of perennial streams may become intermittent, and the degree of intermittency of some of already intermittent streams might increase as well. So research on how these aquatic organisms can persist in these areas is going to be critical for managing them, and is only going to increase in importance as we see more of these streams become intermittent. So the Middle Rio Grande kind of provides a really nice area to answer some of these questions, or at least to start at answering some of these questions, because we have more than 10 years of data on both the drying and silvery minnow and the fish assemblage as well. So disturbance, drought and channel drying is a major disturbance for aquatic organisms. We're going to define it for this presentation as by its damaging properties, which is following lake, rather than the response of the community to disturbance. We're going to talk about the damaging properties, which are the number of minnows that are stranded or possibly killed. And so refugia are the places where the negative effects of disturbance are lower than the surrounding area. So where are these areas that there's fewer fish that are stranded or fewer fish that are killed? So it's important to discover where these places are and how fish are using them, so that we can inform our management decisions, because we're going to see that either fish have to move to these refugial areas, or they're going to be trapped in them at the onset of drying. So I'm just going to go through a few pictures of what it actually looks like as the river dries. It's pretty variable by year. We've seen it as early as April. This is just for the last decade. We've seen it as early as April, as late as September for first drying events. This is just before the river becomes isolated pools. You can see there's just a trickle of flow between those pools. This is one of the larger pools, so you can see it's still kind of narrow at one end and large at the other end. This is also another very large pool, but you can see the majority of it is very shallow. It's only about ankle deep. This is a much more common picture. There's a lot of these pools where they're just these, kind of long, narrow pools that aren't very deep at all. Another common site, this is from 2018. That's a bunch of dead silvery minnows down there by San Marcial. And then this is probably a pool that's been disconnected for 3, 4, maybe up to a week. Those are mostly carp. There are some buffalo and carp suckers in there, and we didn't dig around. I'm sure there's minnows underneath that pile somewhere. So the objectives of this study, we wanted to examine the frequency and persistence of pools and what's the size and the depths of these pools in the Santa Costa Reach. So we really wanted to know how many pools are forming, how big are they, how long do they last? And then we wanted to document and explain these spatial and temporal patterns that silvery minnow occur in these pools. Like, which pools are they occurring in? Is there any pattern? Are they moving out of the areas of drying? So our first hypothesis is kind of the no-brainer: deeper, larger pools persist longer than smaller pools. But more importantly, do these deeper, larger pools contain relatively more silvery minnow than the smaller pools? Now, just because the pool's bigger, you'd automatically assume there should be more fish in it just because there's more volume. So we want to actually see something even more than that. We want to see them avoiding the smaller pools and choosing the larger pools. Number 3, silvery minnow are more abundant in upstream areas. So there's been some research in Australian streams that fish will actually move out of the areas prone to drying before it dries. So we kind of hypothesized, well, if this is happening, we're going to see more fish as we start rescuing fish upstream closer and closer and closer to Santa Costa. They could be going downstream as well. We don't really have any data to answer that one. So we're just looking at, are there more fish upstream as drying continues to get closer and closer to Santa Costa? Are there more fish upstream? And the last one was, does the rate of channel recession affect the number of silvery minnow trapped in isolated pools? So the faster you dry the channel should prevent fish from escaping. So the faster the channel dries, we should be seeing more fish stranded in isolated pools. So study area, not going to go over this, go over it pretty quickly. We focused just on Santa Costa. Why? Because that has the most data. There's more pools, more days, more years that it dried, more fish, more miles. What's highlighted in red is that's the extreme extent of drying over the whole 10 years. That's not representative of any one year. That's just a composite. Just like I said, just 2009 to 2018, focused only on the first drying event. So some previous work that I'd done, fish get redistributed after rewets through the monsoons and other rewetting events. And we were more interested in where are fish prior to drying, not where fish going after they get redistributed through some of these rewetting events. And we only looked at wild fish. We didn't analyze any hatchery fish. So for the pool longevity, we followed 290 pools on the first drying event in 2016. So what we did was we measured the depth. Originally, we were trying to measure the maximum depth of each pool every single day, but that became too tedious. And so we were going back about every other day or every third day, out to 19 days when the river completely reconnected. So when a pool dried, we calculated the maximum number of days that it could have persisted, which means when you see this pool that persisted 9 days, that means we drove by on day 10 and it was dry. So we just assumed that it was wetted on day 9, even if we weren't there to observe it. So all of these maximum days of persistence are going to be biased towards the high end. And then we collected a modified densitometer reading, which is just to get how shaded is each pool. We used a generalized linear model to try to predict how long the pools would last, used AIC to rank them, blah, blah, blah. Here's the interesting stuff. You can see the pools are pretty small. Whoops. Where's the pointer on this thing? So you can see the red bar is the mean maximum depth of the pools. And then the blue bar is the mean plus 1 standard deviation. So the pools are pretty shallow. They're only about 0.25 meters deep. The average pool is only about 0.25 meters deep. And the deeper pools did persist longer. You can look over here. But when you start looking at, pools that persisted 5 days, you're already up here around 0.35. You go to 10 days, you're out here. There's just not, these are only single pools out here at these depths. So there are some bigger pools, but they're really, really infrequent compared to the smaller pools. Canopy cover wasn't meaningful. It's down here. You can ask me questions about that later, but it didn't, even though it was in one of the top ranked model, it didn't really explain anything. Your average persistence was 3.7 days. The vast majority of the pools dried. What you're seeing here is these single pools. This is the final depths. The pools that did actually persist to reconnection, they're very shallow. You got none of them are over 0.25 meters deep. So even the pools that did last for all 19 days, or for however long they were disconnected until the river flows came back, they're very shallow anyway. Only 27 pools out of 290 even persisted, which was 9.3% of all of them. But only 1.4% of silvery minnows occurred in those pools. And we had almost 4,800 minnows. So this is kind of the opposite of what you wanted to see. They're almost avoiding the pools that persisted. And so we kind of lack this data, but just by driving by the pools every day, we kind of noticed that even those ones that did persist, they're not Refugia. There's no fish left in them, or if there were any, it was Gambusia. And just to go back to this really quickly, you can see the cluster, a bunch of pools that persisted are right up here. They're only disconnected for 1 to 3 days. And then you have a bunch down here that lasted 19 days until flows returned. And we're guessing it's probably because there was a shallow groundwater connection. And okay, so then from 2009 to 2018, we ran some multi-season count models. And we only looked at pools that were complete cases. They had a depth, a location, and a count of fish. And that still ended up being, I think, over 3,000 pools. And we summed 1 to 4 passes. The asterisk is just a reminder that I dropped the part where we actually did some repeat sampling and could estimate abundance and detection probability. It was the least interesting of all of this, so skipping that. We used a generalized linear mixed effects model where year was the random effect. And the predictors, the response was the counts of either adults per pool or young of year per pool. So we modeled those two separately. The predictors were the mean May discharge, the day of the year, the distance to the Santa Costia diversion dam, the rate of drying, which we just defined as the number of kilometers that dried the previous 24 hours, and then the maximum depth of each pool. So those fixed effects are kind of measuring the overall population level effects. And we only used the main effects that got real complicated really fast. So I'm sure there's interactions going on, but what we looked at was only combinations of those main effects. We scale predictors, so that's subtracting the mean and dividing by the standard deviation. That lets the models run a little better, and it also lets you compare the parameter estimates because they're going to be on the same scale, and you can use that to gauge an effect size. And then we calculated a marginal R squared, which is just the proportion of variance explained by only the fixed effects, not your entire model. So what we found, pretty good R squared for adults, better for young of year. As we predicted, May stream flow has a strong effect. This is in spawning year. So you have a really strong response rate to how much water there was in May. A little bit surprising is there's fewer adults later, and that's not surprising, there's fewer adults later in the year, but the strong response of young of year to having first drying occurring later in the year, that's because adults are probably dying off throughout the season. Young of year are partly getting recruited to the year, so we're just not able to catch them when they're smaller, but also in these years where you have strong May runoff, you have a lot of young of year, that's gonna be the years where your first drying occurs later in the year anyway. So those two things are kind of entangled. Now you have more adults in deeper pools right here, but look at the effect size, it's not even 0.4, so much smaller effect compared to these two. And for young of year, it overlaps 0, so not really any effect on the depth of the pool. They're just kind of occurring where they occur. There were more adults upstream, but again, not a big effect, and more young of year downstream. And rate of drying, I'm not really sure what to say about this one. The faster you dry the river, the fewer adults you get, and not really any effect on the age 0. So that's kind of counterintuitive. So I'm not 100% sure what that means. So just to revisit, deeper, larger pools do persist longer than smaller pools, but there aren't very many of them. And deeper, larger pools contain more silvery minnow than smaller pools. Not really, they're kind of everywhere. So there was a small effect on adults, but not on young of year. And you look at that 2016 where only 1.4% of them even occurred in pools that persisted. So they're not really specifically choosing those pools that persist. So if you take anything home from this, isolated pools are not refugia for any fish because they don't last long enough and they're not very big. All right, so silvery minnow are more abundant in upstream areas. Yeah, it's true for adults, but not for young of year. There are generally more of them downstream compared to upstream areas. So one possible explanation is that it's because these have semi-buoyant, non-adhesive eggs. There's going to be some net downstream drift that's eventually offset by upstream dispersing adults. And number 4, rate of channel recession will affect the number of silvery minnow trapped in isolated pools. Kind of inconclusive. We saw that more adults are stranded when you dry the river, fewer adults are stranded when you dry the river faster. And I'm guessing this is just a lack of data and a lack of range of rate of drying. We were looking at drying rates of about 0.1 kilometers to 8 kilometers. If we had seen drying rates that went out to 20 or 30 kilometers, we probably would have seen an effect. But don't dry 20 kilometers in a day. And it's also going to be a small effect. You saw how strong the effect of spring runoff and the day of the year was. That's accounting for a lot of the variability. So you're kind of looking for a small effect in a really complex system. All right, so to summarize, if there's drying this magnitude, duration, and frequency throughout the evolution of silvery minnow, we kind of would expect to see them seasonally moving out of these areas, or at least selecting pools that would kind of persist. So historically, they probably persisted because they were widespread and abundant in a barrier-free system. They were above Cochise, they were below Elephant Butte, they could move back in here. Also, we don't really know what drying might have looked like 200 years ago. Maybe there were half-mile long pools that lasted weeks or months. Today, we're only seeing pools that last a week. Most of them last 3.5 days or less. So what I'm saying is channel drying poses a novel environment for these species, and it causes catastrophic mortality, which is from Elliott Tramer. That's not my term. And there are refugia, but the fish have to occur there prior to drying because we're not really seeing any evidence of them moving to these areas. So for Sanacosia, not really very many. If we throw out isolated pools, it's going to be the wetted areas below Sanacosia. And if the pumps don't get turned off at the south boundary, then below the Bosque del Apache Refuge as well.
What about, return flows from drainage?
There aren't really any in Sanacosia. Yeah, that was kind of another, Justin and I have been doing some other work, and he looked at some of the water quality in some of those returns as well.
Yeah, we looked at water quality in the water quality is pretty poor in isolated pools, and there's considerable variability in the drain outfalls, and it's consistent. There's the inner end of variability is low, so we looked at 3 drain outfalls in these letters, and they all respond similarly. 1 to 3 years. And then downstream Santa Casio, we observed suitable thermal conditions for the first kilometer or two, and then after that, it exceeds the temperature thresholds develop largely.
Thanks.
And so kind of what I was getting at is that, yeah, these areas exist, but it's not, I don't think you're going to see fish moving from 5 kilometers downstream to get into these specifically. You're probably going to see fish moving from a couple hundred meters downstream. You know, they're good. Of course, if there's water there, that's better than no water there. But I don't think, say, the Sabinal, you know, you're probably only going to attract fish for a short ways downstream of that. You're not going to be attracting fish all the way from US 60 to move up into that.
Another question, if I may. So do you see opportunity for creating or excavating Refugia?
Yeah, you know, I kind of had that in our manuscripts, and I think for it to be effective, I think you have to create a lot of them, because like I'm saying, I don't think they're going to move to them specifically. So for Refugia to be effective, you just need a lot of them.
Thank you. Good talk, really interesting. So the area that you're working in is in Bosque del Apache, which we know is very much an aggregated system. So it's just a big sand bed, right? I mean, you might have some clay lenses, and I'm kind of curious, it might be worthwhile to go back sometime and kind of do some coring to kind of see where you've got persistent pools, if you're getting a clay lens or something.
Sure.
I'm having a hard time believing it's groundwater, but it could be.
So,
And I did a little bit of that work in this letter that we can share with you. We never published it or anything, but we kind of looked at where the groundwater table was.
right. Yeah, no, that's a good comment. And Justin and I kind of talked about it a little bit. So I'm just going off this from memory. That was the year of the Tiffany fire.
Yeah.
So there was no canopy cover. And the one pool that I'm thinking of was in direct sunlight the entire time. So I mean, and the water was clear. So that's kind of where I inferred that it was probably groundwater. And it's also the year that Dustin chalked up the check dams on the low flow, and it just created quicksand everywhere. So I'm wondering if we just happened to pick a year where they did something a little differently. And it was, I don't know. They were kind of clustered. There's like 2 pools. I'm sorry, I meant to mention that was 35 kilometers that the 290 pools were in. So not even 1 pool per kilometer persisted. But you could see there's the obvious concentration up near the top of drying where it only been disconnected for a couple of days. But there was that other cluster at the bottom. So there were only 2 pools, one that lasted 11 days and one that lasted 9 days, that were kind of caught in the middle of those 2 areas. So yeah, that's a good question.
Yeah. The other thing I wanted to mention is that that's the same area that at least part of it that the realignment's occurring in, and hopefully there'll be 11 months of realignment. Right now there's a pilot channel or pilot realignment going in. So I think it'd be super interesting to see do another study to look at the realignment first, and then you can kind of compare with the channel that's
Sure.
existing right now. So I would suggest that as another research topic.
Sure.